In this video, I'm going to talk about a special type of linear system known as a homogeneous linear system. Some people say homogeneous. I usually say homogeneous. So what is a homogeneous linear system? Well, let's start with what is a homogeneous linear equation. A homogeneous linear equation is something like this. X plus y plus z equals 0. And what makes it homogeneous is the fact that our constant term is 0. So what's a homogeneous linear system? Well, you might just be able to guess. A homogeneous linear system is a linear system where all of the equations are homogeneous. So for instance, 4x minus 3y plus 6z equals 0 is another homogeneous linear equation. And let's add a third, minus x plus y plus 3z equals 0. So this is an example of a homogeneous linear system. So what's special about homogeneous linear systems? Or let's say, why do we care? What's special about this? And I'd give three answers to this. The first answer I would give is nothing. A homogeneous linear system, if we're trying to solve it, we're going to approach it exactly the same way as we would approach any other linear system. It'll be a bit less complicated to solve, I guess, in some sense. That is, we have a bunch of zeros, and anytime you have zeros, that makes the arithmetic a little easier, but we won't do anything differently. So in some sense, there's nothing special about them. Then why have a name for them? Well, they'll show up everywhere. There are so many things in linear algebra where you're trying to do something seemingly unrelated to linear systems, and what you're trying to do boils down to solving a homogeneous linear system. So this is why they have a name, so that we have a way to refer to them, so that we don't have to say something awkward like, oh, a linear system where the constant terms are 0. We have a name for it. But there's one other thing that's special about them, and in order to see this, I want to flip over to a 3D graph. So let's look at our system right here. And I want to put this onto a 3D graph. So x plus y plus z equals 0 now shows up in red. 4x minus 3y plus 6z equals 0 shows up in blue. And minus x plus y plus 3z equals 0 shows up in green. Now, if we look at this, we can see that there appears to be a solution to this system and draw it in. And let's go ahead and add a fourth equation. So I'm going to add one more equation here. And I guess I'll make that one purple. So I'm going to add one more equation, and it's going to be 7x minus y minus z equals 0. I'll put that as well into the graph. And what we'll notice, if I look at this appropriately, is that this also goes through that same point, which isn't crazy, but might be a bit surprising. Generally speaking, we don't necessarily expect, as we start to add more and more equations, for there to continue to be solutions. Oftentimes we end up with an inconsistent system. I mean, that could happen with any number of equations, but as you get more equations, that seems to be more and more likely. And the special fact about homogeneous linear systems that I was mentioning is that they always have at least one solution. And if you look at this graph, you can kind of see that the solution is the origin. These always go through the origin. And so let's write this down. What's special about this? Maybe nothing. Maybe they show up everywhere. But definitely, they always have at least one solution. And in this example, the solution was the origin, all zeros. And that's not a coincidence. if we look back at our system, we can see, oh, wait a second. If we set all of our variables equal to 0, yeah, we're always going to get a solution because we have zeros on the right side, and setting all the variables equal to 0 forces the left side to be 0. So we always have the origin as a solution. So we can get rid of this graph here. So they always have at least one solution. All variables equal to 0. And for our purposes, really the point of this video, I guess, is to mention this fact and to define the term homogeneous linear system, because they do show up everywhere and we'll use that terminology, but we're not going to really do much with them right away because, as I said, there's nothing special about dealing with them in terms of solving systems. The only thing that you can keep in mind when you see a homogeneous system is that you know there is a solution. So you don't have to be worried that you have an inconsistent system. But other than that, homogeneous linear systems work exactly the same as any other system of linear equations.